Hello everyone, so today we will teach you how to evaluate the limits of the function graphically. But before we start, let's define limits and know how to use it when evaluating the graph. And here's Rainfaith Gomez to define the limits of the function.
What is limits? Limits is a backbone of calculus, and through it, we are able to describe clearly what is happening to the function near that constant. As the limit of function, as x approaches to a, which is the constant.
So there are three ways to evaluate the limit by using table of values, graph, or limit theorem. But today, we are only tasked to evaluate the limit by using a graph.
Evaluating the limit of a function graphically, first, we have to identify what kind of a limit the value is. There are two kinds of a limit when identifying the constant. When x approaches a value or constant from the left or true values less than, we can use limit as x approaches to a negative, or limit as x less than a. When x approaches a value or constant from the right or true values greater than the constant, we can use limit as x approaches to a positive, or limit as x greater than a. In addition, one-sided limit only considered on one side of the constant a. Take note, a limit only exists if x approaches to a positive is equal to limit x approaches to a negative. But it does not exist if limit x approaches to a negative is equal to limit x approaches to a positive.
F of a is not the same as the limit of the function as x approaches to a. The f of a is a single number that describes a behavior of the function, which is x is equals to a. On the other hand, limits is a single number that describes a behavior of function near but not at the point of x is equals to a. The possible answer of f of a would be a positive, negative, or zero. And if the whole is shaded. But if the whole is unshaded, the function is undefined. While in limits, regardless whether it is shaded or not, and it meets, it is a limit. But if it does not meet, then the limit does not exist. Take note that the answer is found at the y-axis. So let's proceed to the examples.
So the given is limit of f of x as x approaches to positive 3 from the left. So notice that x is positive 3 from the left and it approaches to 5. And the answer is 5.
Limit of f of x as x approaches to positive 3 from the right. Positive 3 from the right, so it approaches to 2. Take note that regardless if it is shaded or not, it is still a limit. So the answer is 2.
Limit of f of x as x approaches to 3 in both sides. So notice that x is 3 from the left and the right. Take note that the function do not meet in both sides. So the answer does not exist.
The given is f of 3. What we have to do is to do a vertical line test, and what we have here is a shaded and unshaded point. So we have to choose the shaded point, which is 5. We don't choose the unshaded point, which is 2, because the answer would be undefined.
Limit of f of x as x approaches to 0 from the left. 0 from the left, and it approaches also to 0, so the answer is 0.
So the given is the limit of f of x as x approaches to 0 from the right. So notice that the x is 0 and it approaches to 2, so the answer is 2. So the given is the limit of f of x as x approaches to 0 in both sides. So notice that the x is 0 from the left and right, so it do not meet, then the answer would be does not exist. F of 0, so we have to do a vertical line test first, and notice that we have 2 points and we have to choose the shaded point, because if we chose unshaded, our answer would be undefined. So the answer is 2.
Limit of f of x as x approaches 2 from the left. So notice that the x is from the left and it approaches to -2. So the answer is -2.
So that's all for today. Hope you understand our discussion.
Thank you for watching.